This is a 90-minute update on the 17.3 release, and so we'll be going over some of the main items of this release, including any new hardware and some of the new software features as well. This is a quick slide to show you the number of features that are coming in. We have a lot of solutions, a couple of enhancements on the platform/infra side. We have RF enhancements, security, resiliency, and we'll be covering most of these features in the slides today. But given that we have just 90 minutes, we also have a TDM deck that we are working on. So look out for that TDM deck. We are in the process of reviewing that. So we will be putting out that TDM deck, which has a lot more information, configuring many more slides than what we are able to present in this limited time slot today. So these are just some additional features. And, before we go into features, I just want to go over the compatibility matrix. So we are supporting a number of AX access points on this release. We also support the Wave 2s, and the equivalent compatible release on the AirOS side is 810 MR3 and DNA Center. We don't know the exact version yet, the number of the version, but it's the Cyclops release that is going to be in sync with 17.3. From the Spaces side, it is connected 2.2 and Prime's still also supported. Coexistence with DNA Center is still supported with 3.8 MR1. On CMX, the supported version or the compatible version is 10.6.2, and on ICE, it's either 2.6 patch 6 or 2.7 patch 2, and you need the patch 2 for UDN or user-defined network. So let's get into the portfolio update. So basically with 17.3, there are a couple of new AP hardwares that we are releasing. So this is the 9105 AXI and 9105 AXW, which is the wall plate. These are available with 17.3 on iOS XE and 810 MR3 on AirOS. So these actually come in two variants. There is an infrastructure variant, so think of that as a baby brother of the other Catalyst APs like the 9115 and 9120. With the same RF architecture, but we are having 2x2 on the 2.4 and 2x2 on 5 gigahertz. It comes with all the other goodness of AX, so we have MU-MIMO, OFDMA, TWT, and along with the infrastructure variant, we're also introducing a wall plate variant, which is 9105W, which is also following the same RF architecture, but additionally comes with PoE out, and additional Ethernet ports, and a different wall mounting option to add it to the wall. But most importantly, what we want to point out here is that with 9105, our indoor portfolio is going to be complete because now we have the low end, the 9105, all the way going up to 9130. So 9105, this is really ideal for low cost, cost-sensitive Wi-Fi 6 customers. Both of these APs are 2x2 on both bands, and they have a gigabit Ethernet uplink. The infrastructure variant, which is a miniature version of other Catalyst APs, is actually a ceiling mount and comes with all the other Wi-Fi capabilities of AX, and it's also going to be certified by WFA, and we are actually going through the certification process right now. The wall plate variant actually has an M-gig uplink because it also, in addition to AX, it provides 3 wired ports, and it comes with this wall mount option. It is mounted very similar to the 1815W. So form factor-wise, 9105 is a really small form factor. It's really designed to replace the 1815 series. It's a low-cost 2x2. The EWC SKU is not available with 17.3, but it's going to be available with 17.4. So the capability to run a controller on these access points will also be available starting 17.4. It comes with a lot of cool features, like I mentioned, on Wi-Fi 6. So you have the OFDMA, the MU-MIMO. But in addition, there's also a built-in IoT radio for BLE, Zigbee, and Thread. So it has an IoT gateway capability. On the W version, which is the wall plate, it also has the mGig port, the USB 2.0, and PoE out on the wall plate. This is supported both with DNA Center on-prem and DNA Cloud. So it's really low cost. It's easy to deploy for our customers that are looking for a cost-effective solution. If you look at the size of the AP, the 9105 version is really small. In fact, we couldn't use the existing bracket because it's even smaller than the current wall mount bracket. So we have a new bracket for that. This is the internal version. On the side, it's very simple. It's a clean form factor. So it has the gigabit Ethernet port. It has the console and the reset button. And the wall plate actually has this Kensington lock. It has a USB, and the USB puts out 4.5 watts. When you look at the back, it has an uplink, obviously, the controller, but it also has this pass-through port, very similar to the other wall plate variants, that allows you to pass through, for example, a phone on the wall to the bottom of the AP. And there are additionally 3 Ethernet ports as well. The first of these ports does 15.4 watts PoE out, assuming that you're feeding the AP 30 watts. As far as FIPS is concerned, so this has been a question for other APs as well, not just 9105, and we are planning for FIPS certification in 17.3, and that is targeted roughly by the end of 2020. So before we go into key features of 17.3, I want to go over one of the solutions that is really top of mind for many people right now, given the current situation and people working remotely from home locations and micro offices. And this is the remote workspace network solution. Because the idea of business, as we know right now, has been redefined, and this short-term change may in fact be the new normal. So your Teleworker solution extends the secure connectivity of a corporate enterprise network to remote users at home. And this way, remote users can have the same level of application experience and security as they have in a corporate office, because the data between the two locations, between the OEAP and the controller, is protected with data DTLS. In addition, your IT administrator can provision, manage, and deploy consistent policies across all the access points distributed across different homes and different remote locations. And just to clarify, this solution has been there even prior to 17.3, but now is being relaunched with additional testing of use cases with 17.3 and 8.10 MR3. So the Cisco Teleworker solution offers the same SSID as that which is, supporting data and voice inside the enterprise, and it extends that SSID seamlessly over to the user's home location. The controller should really be placed in the DMZ, and the corporate firewall must allow your CAPWAP control and CAPWAP data traffic through the firewall to the wireless LAN controller. So the way it works is that a user is given an AP. It's primed with the IP address of the controller, or the user can prime this IP themselves. The third option is that an administrator can utilize what's called Cisco Plug and Play. And using Plug and Play, they can auto-discover the controller and get some of the config. Once the access point joins the controller, it then advertises this corporate SSID, and it extends the same security method, it extends the same services across the WAN to the user's home location. And you can see in this picture here that SSID is the one that's represented in the green color. In addition, if you have an RLAN, if you have devices connected, your local devices can also be connected to the corporate network via your wired LAN ports. And the really big benefit here with OEAP is that the user can also additionally define or configure a personal SSID or multiple personal SSIDs on the access point for home networking. So this is actually represented in the yellow color here. And so you can see that any local services like home printers, etc., do not have to be sent all the way back over CAPWAP to the wireless LAN controller, and they can all be switched locally. So the solution essentially comprises of access points, which are either Wave 2 indoor or any of your AX 9100 series access points. The 9105I and W are also great options for OEAP because of their sleek design and also because they deliver full Wi-Fi 6 performance. The important thing to note here is that the controller needs to have a public routable IP so that remote APs can reach it, and this public IP can be added as a NAT IP on the wireless management interface on the config of the controller. So this is the slide that explains the zero-touch experience that I was just mentioning earlier, where customers can use plug-and-play that's set up by the administrator to pre-provision the site and to add Cisco access points to that site. And this includes, entering access point information, or even better, you can add what's called a $0 PNP SKU while ordering the access point. And that automatically adds the AP information to the plug-and-play Connect account, which is associated with the customer's smart account. So when a teleworker solution, a teleworker user powers up the access point, it auto-discovers this cloud PNP server by using a DNS or cloud redirect service through devicehelper.cisco.com. And after this auto-discovery is complete, the AP downloads the config from a cloud PNP and then communicates with the controller. So you don't really have to set up the access point prior to sending it to the teleworker's home. We also support split tunnel, and this is the reason we support this is because users at home are using a number of applications that actually do not need to go all the way back to the corporate headquarters in this CapTap tunnel, because that causes extra latency. It also consumes bandwidth. So split tunneling is really a mechanism by which your traffic can be locally switched if it matches the 5-tuple IP ACL. And so any packets that match the ACL will be switched locally, and any packets that don't match the ACL are going to be centrally switched over CapTap back to the headquarters or back to the controller. So coming in to the next section, which is really talking about infrastructure updates, there are a couple of important ones on this section. The first one is that we have improved the throughput of the 9800 private cloud variants. We've done this in 3 ways, and we'll go through what those are. And the first one is really to introduce high throughput templates. So these high throughput templates increase throughput in the order of about 30% compared to the low throughput templates. And these templates actually require 3 additional vCPUs. So you can see here on this table that the 3 additional templates, small, medium, and large, for high throughput will now be available with 17.3. And also just note that starting 17.3, the disk recommendation for all 9800 cloud will be at least 16 GB, which is indicated in the slide here on the row against required storage. So what happens when you allocate these 3 additional vCPUs? Where are they really allocated? So this slide shows you a split of cores between the control plane and the data plane functions across all the templates. So you can see that we have the small high, small medium, and small large, and you can see that 3 extra vCPUs are allocated over here to the data plane. So deploying through 17.3 base OVA will now show you 6 supported templates. As you can see, the number of APs and clients for the small, medium, and large don't change, but really what changes is the throughput across these templates. So starting 17.3 on ESXi and KVM, we also support SRIOV. And SRIOV is essentially a specification which allows a PCI device to appear as multiple separate physical PCI devices. So every virtual machine is directly assigned and given access to the physical resources by the hypervisor. And this results essentially in improved north-south network performance by allowing the traffic to bypass the host's network stack. And so this actually causes a lot more performance improvement in addition to the high throughput templates. And here are actually some initial, so this is just the, for your reference slide. And the reference slide talks about the hypervisor version, the NIC version, and the associated driver versions. But I think what's interesting to note is this throughput measurement, which we had in 17.3, and this is done as part of EFT, as part of the customer's network, where you can see that there is a significant increase in throughput when combined with SRIOV. The throughput goes up nearly to 6 GB on ESXi, whereas with prior to 17.3, it was just 2.1 gig. And with KVM also, it was 1.2, and now with the SRIOV and high profile, it's 4.7. So that is a significant improvement by many orders in 17.3 with ESXi and KVM. SRIOV is not supported on Hyper-V. So on Hyper-V, all you'll have is the high throughput template. So the second really important update on the platform side is the introduction of the embedded wireless non-SDA on 9K switch. So we've had embedded wireless in SDA, and that was available even prior to 17.3. So you could turn on wireless functionality on switches if you're using SDA, which is depicted here on the left-hand side. So now what we are doing is we are turning on single site wireless in a non-SDA deployment. So what you see on the right-hand side, this is new with 17.3. And this is supported on the 9300L, 9300, 9400, and 9500. This table down here shows you really what variants are supported. The 9300L has half the scale of the other ones, but the other ones actually go all the way up to 200 APs and 4,000 clients. And really on the same site, you can have up to 2 switches, which gives the total scale of 400 APs and 8,000 clients in a single site. So this is the same as earlier, but now, what's different is that this switch is non-SDA. It does need the DNA Advantage license, so just keep that in mind. And, going a little bit deeper into the architecture, you can see that there are 2 stacks here on a single site. So this image is showing you a deployment where there are 2 switches or 2 switch stacks, and they can independently be in SSO mode. They can also do N+1 between each other. So the control plane is really going to work over CAPWAP from the APs to the controller, and the data plane is going to be VXLAN tunnels. Both directly and indirectly connected APs are supported in this mode. And again, from an AP standpoint, we support all Wi-Fi 6 APs, all indoor Wave 2 APs that are supported in 17.3, and also the outdoor Wave 2 APs in local mode. The management and enablement is very specific, and it can only be done from the web UI. We have a new embedded wireless setup option, as you can see on the first screenshot here. I don't know if this is legible enough, but we have a new embedded wireless setup option on the web UI. It's very similar to the basic setup on the standard 9800 controller. And you can see that once you enable embedded wireless setup, you can go in, create locations. Within the location, you can create SSIDs, you can allocate policies to that, and then you can associate that with access points. And so once you do that, all of the config that's needed in the backend is completely seamlessly pushed down to the backend. So the user really does not have to worry about profiles or tags. It's a very simplified way of configuring this box. And if you're familiar with the basic setup, this should be very similar to what we do on the standard 9800. this is a for your reference slide with all the features supported. And as you can see, we have high feature parity between the 9800 and this embedded wireless and non-SD mode on the Cat9K. So we're shifting gears and starting to talk about RF here, and we have a number of cool things with RF that we're bringing in with 17.3. The first of those is spectrum intelligence, and so far with the 9800, we have supported this on the 1800 series wave 2 access points, and with 17.3, now we're introducing this on the 9115. And also on the 9105, which is newly introduced with 17.3. So why really do we need SI? So Wi-Fi basically operates in the unlicensed 2.4 and 5 gigahertz band. And many devices like your microwave ovens, cordless phones, Bluetooth devices also operate in these bands, and they can severely impact Wi-Fi performance. So the idea here is that we want to scan these interference devices and move APs off of those channels. So spectrum intelligence, it scans non-Wi-Fi radio interference on both 2.4 and 5 gigahertz, and it provides you basic functions to detect interference of various types. For example, microwave ovens which operate in 2.4 gigahertz band, video cameras, frequency hopping like Bluetooth, and frequency hopping spread spectrum cordless phones. So it detects all of those types of devices, and actually you can see here it actually 6 common kinds of non-Wi-Fi interference are detected by spectrum intelligence. So SI is enabled on the network. You can enable it under 2.4 and 5 gigahertz band, and it can be monitored the same way as Clean Air. So you go into the Clean Air statistics, and it shows you the 9115, and if you have a 9105, it's also going to show up as a separate row, and it's going to show you that the top interferer that it detects. But there's clearly a difference between Clean Air and spectrum intelligence. So one of them is that unless you set this AP to monitor mode, it will only show you interference on channel events. So if you're seeing this interferer, you will only see the affected channel, which is the same channel as the AP is doing client serving on. Also, SI cannot differentiate between multiple devices of the same type, and only one alert is displayed regardless, if there are 1 device or 10 devices. And the most damaging interference is shown every time. So if you have a video camera, that is going to be displayed over a microwave oven, and the microwave oven is actually going to beat out a cordless phone or a Bluetooth device. So these are some restrictions to keep in mind. So it's not as awesome as Clean Air, but it's also it's equivalent to what our competitors offer on these low-cost access points. So this is what we have with the low-cost options like the 9115 and the 9105. So the 9130, as you know, it has a really cool differentiating feature compared to the rest of the access points. It's called Tri-Radio. What this means is that we can run 8x8 5 gigahertz or dual 4x4 5 gigahertz radios on the 9130. So this feature has been there even prior to 17.3, but I'll highlight in these slides really what's new with 17.3, specifically. So the default mode on 9130s is 5 gigahertz 8x8 and a 2.4 gigahertz 4x4 mode. And this default mode provides the highest throughput per single radio with performance gains mainly in MU-MIMO client environments. However, there are instances when it becomes beneficial to change the operation of this access point to 2 independent 5 gigahertz 4x4 radios. And the benefit with the dual 5 gigahertz 4x4 radios is that it allows for macro-micro cell operation, which is really useful in high density environments, and also permits you to have more clients for greater performance when there are fewer Wi-Fi 6 capable clients. So FRA, essentially what it does is it allows you to operate these access points intelligently and determine the operating mode of serving radios based on the RF environment and the traffic demands. So your access point can dynamically switch between a dual radio mode, which is the 8x8 5 gigahertz and 4x4 2.4 gigahertz, and the Tri-Radio mode, which is dual 4x4 5 gigahertz and one 4x4 2.4 gigahertz. So FRA is basically giving you the capability of switching between these two modes dynamically based on what is going on in the network right now. So furthermore, in this table is really helpful to visualize what's going on with FRA and Tri-Radio. So you can have the 8x8 client serving, and in that case, radio 2 is turned off, or you can have 4x4 both on radio 1 and radio 2, and both of these can be client serving. But FRA can also switch between client serving and monitor mode, depending on if there are enough 5 gigahertz radios in the network. So yeah, these are sort of the three modes that you can switch through. And prior to 17.3, you could only statically or manually assign the radio or the AP as an 8x8 or dual 4x4. But with FRA in 17.3, we have the auto option. And the auto option basically allows you to switch through all three modes in a dynamic fashion. So the first thing to remember when you're configuring Tri-Radio is that Tri-Radio is disabled by default. So when you start up an AP, Tri-Radio needs to be enabled. You can enable that by going into the 5 gigahertz network and turning that on. And what this does is that it gets the hardware ready for Tri-Radio support, but slot 2 is still in the disabled state. So as you can see here, slot 0 and 1 are enabled. Slot 0 is 2.4 gigahertz. Slot 1 is the first 5 gigahertz radio, and slot 2 is the second one. And the second radio, slot 2, is actually in the disabled state. So when this happens, you want to go into the software configuration and actually turn on this slot 2. And the way you can do that is by going back into the 5 gigahertz config, and under Tri-Radio support, you see three options. You see auto, you see enabled, and disabled. So what is new with 17.3, as I was saying, is this auto option. So let me go through what these three options are, and that gives you a little bit more clarity. So disabled and enabled was supported prior to 17.3. Disabled is the default, which means that it's a single 8x8 5 gigahertz radio. If you choose enabled, that statically assigns two 4x4 5 gigahertz to slot 1 and slot 2. And in this case, the slot 2 will have to be manually enabled. And third option, which is auto, and that's new in 17.3, is where FRA takes control and assigns the radio roles to the two 4x4 radios, either as client serving on monitor, and it automatically also enables slot 2. And really what's also very awesome with 17.3 is that moving between these modes, between dual and Tri-Radio, does not need a reboot or a cap-app reset. So it's a lot more seamless, and it's all done by RRM. So there are a number of other RF-specific features as well, and in the interest of time, I'm going to talk through this particular table to show you all the different features. So a big one right at the top here is Wi-Fi 6 analytics, and this is really useful in demonstrating value and driving adoption, because it shows metrics related to a customer's existing network in terms of how many Wi-Fi 6 clients do they have, how many Wi-Fi 6 access points are in their network, and what is the level of readiness of Wi-Fi 6. And they can view this by site, by SSID, and by band. So this really helps to push the business case for installing more Wi-Fi 6 in customers' network and driving adoption, because they're really able to visualize and see and evaluate their network to see where the gaps are and what kind of Wi-Fi 6 equipment they need to bring in order to see better metrics on performance. So once your Wi-Fi 6 access points are installed, as an administrator, you want metrics to justify why you just installed a whole lot of Wi-Fi 6 and what is the performance improvement. So there are, again, more metrics on DNA Center, such as how much is it better with voice, how do the non-Wi-Fi versus Wi-Fi sites compare in terms of airtime efficiency, and how do they impact other services in the network, for example, metrics on latency and client experience. So this is now part of 17.3, and you can see that this is across all our different access points, including the Wave 2s. So yeah, this is something that's visualized on DNA Center, but the support for that, sending the data, is coming in from a 17.3 controller. Couple of other important things here is that full packet capture and spectrum analysis is available also now on the 9130. So intelligent capture along with spectrum view harnesses the power of your Cisco RF ASIC that is built into the 9120s and 9130 access points. Spectrum analysis on 9120 was already a part of 17.2, but now with 17.3 we also have this available on the 9130. So when you combine that with DNA Center, it really quickly provides a way to view the critical visibility and intelligence that is needed on full spectrum in real time 24/7. So both of these features are pretty big, and that basically completes a lot of the features from an ICAP perspective on the 9130. So coming into the security aspect of 17.3, we have a couple of cool things. One is we've made some enhancements on rogues, and second is we have additional attacks that are part of the base signature on the 9800. So let's go into the rogues first, and then I'll talk through what's different with WIP. So the first thing around rogues is around containment. When the detected rogue is using PMF, Protected Management Frames, or 802.11w. And this essentially, the issue here is that when a rogue does that, we cannot contain that rogue because you cannot sign the deassociation or deauthentication messages for that rogue. So instead of unnecessarily starting containment and failing, which actually wastes a lot of AP resources, we just move the AP to containing or contained pending, which is, you can see the message here on the slide, and we put in a reason, which is PMF enabled, cannot contain. And the reason we do this is because we know that even if we did try to contain this rogue AP, we would not be able to do that because we are not able to sign the deassociation or deauthentication messages, and that is going to fail. So we're just going to put in a message there for the admin and not going to spend any AP resources trying to contain that rogue AP. So you can see that this is what it looks like on the UI. So when you go into monitoring wireless rogues, you can see that the status shows containment pending, and you can see the reason for that is because it is on PMF. The second set of enhancements for rogue is around enhancing detection of rogue impersonation. So 17.3 adds additional information about the DS parameter, and the DS parameter is one that actually indicates the channel number that's used by the rogue AP. So if an impersonation attack is detected, we check to see if the channel that's being used by the rogue matches any of the recent channels by any of our managed access points. And ideally, if it weren't a rogue AP, it should match one of the channels that are recently used. But if it's a rogue, it's not going to match that. And once we detect that case, we raise that as an alarm in RWSA. also, another way to detect or better the rogue impersonation is using something called AP authentication. So all Cisco APs in the same RF network, they share what's called a domain secret, and this domain secret allows them to authenticate each other. This is present in beacons. It's also present in probe responses. And if the AP authentication information element has an incorrect signature or an incorrect timestamp, or the AP authentication information element is completely missing, the rogue is actually moved to a malicious list and it's marked as a threat. And this feature can be enabled. It can be enabled on the web UI. But the previous one that I talked about, the one which it matches the DS parameter on channel, that is enabled by default. So this is showing you how to enable this AP authentication. So you go into configuration, security, wireless protection policies, and under that you can see AP authentication. And when you enable this, it basically cross-checks this authentication field, and on a rogue AP, this authentication IE is going to be missing. And so once you detect that, you can mark it, and then you can move it to a threat. The third way that we are reinforcing this mechanism of detecting the AP impersonation is using infrastructure MFP. So infra MFP actually adds what's called a message integrity check to the management frames that are transmitted by Cisco managed APs. And this way, your Cisco managed APs can validate other APs when they hear them over the air. When infra MFP is enabled and managed APs find that there is, that there is an access point where the message integrity check is missing or it's not as expected, it gets flagged and it gets basically added to the rogue report, and that's detected as rogue impersonation. So all three of these, which is the DS parameter set, the AP authentication parameter information element, and the message integrity check, all of them help us to detect rogue APs in a much more confident way. So you have three methods, and once you have any of these, you're kind of confident that this is a rogue access point. So that's pretty much what the enhancement on the rogue side is. And again, you can enable the infrastructure MFP also on the web UI. So under the same page, wireless protection policies, there is an MFP config, and if this is enabled, then the infrastructure access points will check for this message integrity check across all the APs and be able to detect this rogue access point. Now on the WIP side, so WIPs essentially is our embedded wireless threat detection solution. It also helps with mitigation of the wireless network infrastructure against attacks. And here this shows you all of the attacks that are supported prior to 17.3. These are detected over the air. And you can see that we have a number of attacks that are already supported on the controller, but with 17.3 we have 2 additional alarms. And these are essentially for detecting CTS floods and RTS association request attacks. And what these attacks are essentially is that they are denial of service, where an attacker can take advantage of the privilege that's granted to these RTS and CTS frames. So RTS is request to send and CTS is clear to send frames. And these 2 frames have a lot of privilege because they can reserve the RF medium for transmission. So an attacker who's trying to have a denial of service attack will be transmitting these CTS and RTS frames back to back with a large transmission duration. And this way they're able to reserve the wireless medium and force other wireless devices that are sharing the RF medium to hold back their transmission. So it's a pretty severe kind of denial of service. So with 17.3 now, we have the capability to detect these 2 types of attacks in addition to the previous ones, and they are now added to the base signature on the 9800. So again, VIPs signatures are supported across the different deployment modes. They're supported on local, they're supported on Flex, and also Fabric. They're supported on all of the variants of your 9800, so be it on the access point, or switch, physical form factor, private and public cloud. And on the access point side, we support this on the Wave 2s and on the AX access points. And this is supported in local mode, Flex mode, and monitor mode. From a resiliency perspective, the big one here is ISSU, and ISSU was supported in 17.1 and 17.2, but it was just in the beta phase. So now with 17.3, it's going to be general availability, and this is actually pretty big because we've had this request for years, and we did not have the capability to support this on our AirOS platforms, but because 9800 is based on the architecture of iOS XE, we are able to leverage the benefit and are able to provide this in-service software upgrade solution to the 9800. Big benefits that ISSU offers is that first, it eliminates downtime in the network, and our customers are able to upgrade their production networks without waiting several weeks to schedule a downtime. The second big benefit here is that you don't need an additional N+1 controller purely for the purposes of the upgrade. You can utilize the active and hot standby pair that you already have and upgrade the network without a downtime. And the third is that this is a completely automated process. There is no need for manual intervention. There's no need for an external orchestrator. It is all done and capable to do this with just the web UI of the 9800 controller. The prerequisites here are that the base image needs to be ISSU capable. So in this case, it's going to be 17.3 and higher. Obviously, the two controllers need to be in SSO, so they need to be in active hot standby. And the controllers also need to be in install mode. So as long as you have these three prerequisites, you can have upgrades using ISSU or in-service software upgrades. So the ISSU workflow, the way we achieve this is that we utilize the base SSO capability, and that's been enhanced in a couple of key ways to enable the in-service software upgrades. So the process essentially begins up here on the top left corner, where we load the image onto the active controller. It seamlessly syncs over to the standby. Once it syncs over, we also pre-download it to the access points that are connected to the active controller, and we reload the standby at that time. So the standby reloads, comes back up with V2, it syncs with V1 and reforms the SSO pair. So that's the first enhancement which enables this, where we are now able to create an SSO pair between V1 and V2. Once this happens, a switchover takes place, and the switchover then allows the V2 to become the active, and as a result of rebooting the old active, it comes back on V2 on the standby. So now both controllers are on V2, but your access points are still running V1, and that's the second enhancement with SSO that allows this to be possible, where now for the duration of the ISSU process, we are able to manage access points that are running V1 on controllers that are running V2. So now in order to upgrade these access points, the system will kickstart what's called a rolling AP upgrade. And the idea with the rolling AP upgrade is that we want to upgrade access points in a staggered manner, such that not all access points will reload at the same time, but based on an RRM candidate AP selection, we will pick out AP upgrade groups and have several iterations of reloading access points, such that there are always APs available in order to provide RF coverage to clients. So once rolling AP upgrade completes, your entire system, including your controllers and APs, are upgraded to V2, and that process is now complete. The other thing that also makes this even better and zero downtime is that we support client steering. And client steering is for candidate APs. So when your access point is selected to be rebooted, that's called a candidate AP. and it could have clients connected to it that need to be steered away. So the way we do that is that we steer these clients away using 11v packets, and these packets are set with the dissociation imminent field. And what this means is that if the client does not switch over to another access point, eventually it is going to be disconnected. So we're sort of giving a heads up to these clients that are connected to the candidate AP that you need to roam over to other access points. And the suggested AP is also noted within the 11v packet. And once all of your clients move away from the candidate APs are reloaded. And this way you're able to take care of clients as well as access points in the network. This is just showing you what the workflow looks like. This is the UI screenshot, and when you go into software management, you can see that there is a very simple way to enable ISSU. You enable this checkbox, you make sure it's in install mode, you load the image that you want to upgrade to, which is V2, and you can just click on download and install. And once you click on this, from that point on, the system takes over and there is no more manual intervention required. So it takes care of syncing the image to the standby, it takes care of pre-downloading to the access points, takes care of reloading the standby, doing a switch over, and then also finally takes care of kickstarting the rolling AP upgrade. And all of those functions can actually be monitored here on the right-hand side. There is a status, a dialog box, and you can expand this, and this goes into all of the logs that are related to this upgrade process. Once it's complete, you'll see that there is a check mark that is against all of those. So you can see where you are in the process. And once your AP upgrade is complete, you can install, you could do an install commit. And what the install commit does is it makes it permanent. So if you don't do this install commit, it's kind of like in a trial phase, and an auto abort timer is started. So if you don't install commit for 6 hours, by default, the system is going to abort and go back to V1. But the abort also is going to happen in the ISSU base. There's really no disruption to the network, but basically we are giving the user an option to try it out. And if they really don't do a commit for 6 hours, which is actually the default, the system will auto abort. Once you do an install commit, those changes become permanent. And after that point on, if you want to revert back to V1, you need to use either a downgrade or a rollback option. There's also a link to the demo. So we have a demo that we created, which is a video demo. So if you're interested, you can actually go to this link. I believe you have the slides after the session, so you'll be able to go into this demo and download the demo. So from an mDNS standpoint, the mDNS feature, as you know, has been there on the 9800 for a while now, starting 16.10. But what's new with 17.3 is that we have the mDNS gateway capability on the FlexConnect APs and on EWC. So our FlexConnect APs will be supporting a maximum of 1,024 clients or service providers per FlexConnect site. And the way we arrive at this number, 1,024, is that we support 64 services. And services can be iTunes or AirPlay or AirPrint, etc. And we support up to 16 instances of these services. So 16 service providers of each type of service. So when you multiply that, it results in this number, 1,024. So using the gateway database and the function implemented on these FlexConnect APs, these APs can distribute the mDNS service information across IP subnets to clients without the need of the controller. The only time you need the controller is in the initial phase of config. But once everything is configured and pushed onto the access point, the APs can also operate in standalone mode. So you don't really need to have this connection between the site and the controller in order for mDNS to work. There is this AP that's selected as the master AP in the site, and that is going to then export some data back to the controller for central management, but that's also the access point that is going to have the bonjour cache or the mDNS cache on your Flex site. Just like on the controller, we also can have mDNS running in 3 modes on the FlexConnect access point. So your AP can be in mDNS gateway mode, which is the mDNS snoop mode, and in this mode, the AP will actually snoop the mDNS packets coming from all of these services, and it will provide a gateway functionality. So you can see that the gateway is going to be on the AP itself. It doesn't need to go back to the controller in order to get the function. So when a client makes a request, if you have the mDNS gateway function running on the access point, it just looks up its local bonjour cache and responds to clients within the same site. You can also have a bridge mode, and this is actually the default mode. And in this mode, the AP is simply going to forward the mDNS packets as if the AP doesn't really care about the packet type. So it's not going to cache anything. It's not going to snoop it. So there's going to be a lot more mDNS traffic on the wide infrastructure at the site. So it's not ideal. So ideally what you want to have is the mDNS gateway mode. If you completely want to drop all of this traffic, the mDNS traffic, there is also an mDNS drop mode. And in this case, the AP will neither snoop nor learn the mDNS packet. It's just going to drop the packet, so clients cannot discover any service providers. However, the wired clients can still discover wired service providers, provided that they're in the same VLAN. So only the wired services will work, but anything else that's over wireless is going to be dropped. So it's going to be sort of like a complete blackout of all the other wireless services in your site. So app hosting actually is a really cool solution that we have introduced with 17.3 and a combination of DNA Center. And Cisco's app hosting on the Catalyst APs at a high level essentially provides customers with the ability to load third-party containerized iOS applications directly onto Cisco APs and to leverage them as IoT gateways. So once loaded, these third-party applications, they can gain access to AP hardware and software resources, and depending on the iOS application that's being developed, it can have the ability to communicate with third-party software using its VLAN and using its hardware like the external-facing USB port. The big benefit here is that we are supporting this on all of our AX access points and the 9840s, 80s, L, and the cloud version. So this is going to be 17.3.1 and above, and on Cisco DNA Assurance, it's going to be 2.1.1 and above. And I was saying, the big benefit here is that a lot of our customers already have Cisco APs that are powering their wireless infrastructure, and they have Cisco APs deployed all through the enterprise. So with the ability, for third-party vendors to create apps and leverage these APs as IoT gateways, it really creates a huge base of opportunities for the IoT market. And so this is, it's a very forward-looking solution because, as you know, lots and lots of IoT applications are coming out in the market right now. So we are able to leverage the installed base of existing APs and able to push containerized iOS applications onto the access points so that they can then communicate with other IoT devices in the network. So Cisco DNA Center is the one which provides the option for you to download an application hosting package called, it's downloaded, it's installed on top of the base DNA Center software. And this is the workflow, which basically shows you the day 0, day 1, and day 2. So day 0 is onboarding, day 1 is config, and day 2 is monitoring. So, just to describe the workflow a little bit more in detail, on day 0, the Cisco DNA Center day 0 configs are going to be done. So you will create a network hierarchy. So, define areas and buildings and floor via the network hierarchy page. You can also configure network hierarchy settings via the network settings page. And once that's done, you'll be discovering the controller and access points in the discovery page and assigning these controllers and APs to the network hierarchy created in the inventory. So this is all part of day 0. It's basically setting up your, basic network hierarchy and discovering devices. Once day 0 is complete, the next step is day 1, and this is where you will upload and deploy your IOX application. So the way that you would do this is that you would upload a third-party IOX application to DNA Center via the IoT services page. There's a special page, a separate page, where you can go in and install this as a package. And then once you install this on the IoT services page, you can then deploy this uploaded application to specific access points within DNA Center. Day 2 is really about monitoring the iOS application. So you will configure third-party applications, third-party management systems to start to begin managing and monitoring these applications deployed on the APs. And really a real-life use case here is ESL, and that's electronic shelf labeling. And at a high level, the ESL application essentially leverages the USB port on the access point to communicate with electronic shelf labels through a USB Bluetooth dongle. And the benefit of the ESL solution is that your prices on shelf items can be updated remotely, and customers also in the store can easily locate the item through their mobile app. So it's all sort of digital as compared to analog shelf labels. So this is accomplished by allowing your ESLs deployed throughout the store to communicate with the various ESL applications using a USB Bluetooth dongle loaded on Cisco APs, which are also deployed essentially throughout the store. And all of your deployed ESL applications are going to then be managed by a central ESL management system. So it allows for an organized end-to-end solution. So the big benefits here are we can leverage the hugely installed Cisco AP base in our customers' networks. And second is that you're able to centrally manage these systems using DNA Center, and you have a very organized end-to-end network solution.